Today we're going to be talking about lesson 49 in your book, which is using the binomial theorem. But before we get to that, let me describe to you some of the problems that sometimes we face in math. For example, maybe we are going to try to multiply a polynomial like this. Well, you say, Miss Holly, I know how to do this. This is not a problem at all. All I have to do is remember to FOIL x plus 2 times x plus 2, and I get x squared plus 4x plus 4. Okay? And that's right. You would be exactly correct in doing that. But say maybe we need to do something a little bigger than that. Maybe we need to cube it instead. So then what we do is we take the squared product and we multiply that again by that same x plus 2. So to do this, again, we have to use our, what's it called? Essentially FOIL again, but this time since we're having three terms, FOIL doesn't quite work. We're just going to use the distributive property. And we're going to start by doing x cubed plus 4x squared plus 4x plus 2x squared plus 8x plus 8. Add them together and we end up with x cubed plus 6x squared plus 12x plus 8. Oh, okay, well, that wasn't as much fun, but still, it's not such a big deal. And, well, you know, I wasn't completely honest. We actually have to find x plus 2 to the 4th power. So what do we do here? We take the cubed answer and we multiply that times x plus 2 again. And now, of course, we go through our distributive property again, and we find that we end up with x to the 4th plus 6x cubed plus 12x squared plus 8x plus 2x cubed plus 12x squared plus 24x plus 16. Okay, now all we have to do is add them together. So we end up with x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. Wow, now that's a lot of work. But maybe I wasn't completely honest, and what we actually need to do is x plus 2 to the 10th power. And we're going to have to keep going and going and going until we get to that 10th power. Now remember, this is only equal to x plus 2 to the 4th. So we've got quite a ways to go. Who's with me for working that all the way out? What? I don't hear anything from many of you. You're saying that you really don't want to multiply that out like this? You're telling me that you want a shortcut to do this. Oh, I see. Well, let me see if I can help you out with that. So here we go. We are going to actually take another step back, and we're going to remember something that we talked about several weeks ago, something called Pascal's triangle. And Pascal's triangle is this neat little triangle that if we start with 1 at the top and we pretend that it's surrounded by zeros, we're going to add our numbers together above, and on the diagonal below it, we're going to put our answer. So we end up with a 1 and a 1 and a 1 and a 1. And it's not really very interesting here until we start adding our 1's together. Oh, 1 plus 1 is actually 2, and we have a 1. And then we're going to have 1, 3, 3, 1, 1, 4, 6, 4, 1. Does anybody remember this? And then 1, 5, 10, 10, 5, 1. And all the way down, we can keep going and going and going, right? Well, these are really interesting numbers. We can keep going. This is kind of fun. It's actually kind of therapeutic, maybe, wouldn't you say? And it's really not hard to figure out. We could go on for a long time, huh? And we really notice that we can see the symmetry developing here. We've got 3, and if I put my marker right down this line, you can see that everything is completely symmetric. All the numbers are symmetric on either side of my marker, which is kind of an interesting thing as well. But what's really interesting about this is that this can help us figure out the answer to this. If you really want to know why and you want to make your homework easier, you will stick with me for another few minutes. Okay. Let's actually come back to this little nifty triangle again. There's another thing that we can notice about these. These numbers are really important because if you think about combinations and permutations, which we talked about a few weeks ago, you'll remember that we had this little shorthand way of saying, I don't know, 0 choose 0, right? And if we have 0 objects and we wanted to choose none of them, well, there's exactly one way that we could do that. We could also go 1 choose 0, and we can go 1 choose 1. And there's one way we can do that, and one way we can do that. We can also do 1, excuse me, we're on the second row now, so we're going to have, now we have 2 objects and we want to choose 0. We can have 2 objects, we can choose 1, or we have 2 objects and we can choose 2. And there's exactly one way we can choose 0. There are 2 ways that we could choose one of those objects, and there's one way that we could choose 2 of them. And you can continue this pattern down just like Pascal's triangle, right? Keep going. 3 choose 2, and 3 choose 3. And the interesting things about these numbers is that they're going to end up being exactly the same numbers that we had just calculated when we were just figuring out the pattern of Pascal's triangle before. So when we do this, 0 choose 0 is going to be 1, just like this. 1 choose 0 is going to be 1, and 1 choose 1 is going to be this one. And 2 choose 0 is 1, 2 choose 1 is 2, and 2 choose 2 is 1. And you can keep following that example all the way down, should you desire to do so. It's more than just an interesting pattern. Both of these triangles, or it's actually the same triangle, Pascal's triangle, shows up in helping us multiply polynomials of higher degrees in something that's called the binomial theorem. Now, the binomial theorem is written out in your book on the top of page 349, and when you look at it, it looks a little confusing, so let me help you break it down a little bit more. And in order to do that, I am going to just do an example. For example, let's do example 2, where we have x plus y, and we're going to take that to the 5th power. There are 2 different pieces to the pattern. The first piece is going to be the coefficients, and the second piece is going to be the variables and the exponents that are associated with these variables. So I'm going to write down the variables first, and then we can always fill in the coefficients later. So take my word for it right now, and you can prove it to yourself later, that when I do this, my variables are going to show up like this. I'm going to start with x to the 5th and y to the 0, which is 1. And then I'm going to add an x to the 4th y, and then x cubed y squared. And then I'm going to get an x to the 4th y. I'm sorry, that should be squared now. Should be counting down there. And y should be going up to the 3rd power. And then x, y to the 4th. And I'm running out of room on my paper, so I'm going to write this one down below. I'm going to finally get a y to the 5th. Now see what happened with my exponents. I started out with x to the 5th. And then as every term went down, I decreased that exponent on the x term by 1. So it goes 5, 4, 3, 2, 1, and then x to the 0. While I was decreasing the x exponent, I'm increasing the y exponent. And so here I have y to the 0, 1, 2, 3, 4, and 5. And when I stick them together, I notice that the degree of every single one of these terms, the degree is 5. When I add the exponents up on the x and the y, I always get 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. And that pattern of exponents is going to show up in every single time you do an expansion of a polynomial like this. So that is how you take care of the variable part of your expansion. But we still have to do the coefficients, the numbers in fronts. And this is where the Pythagorean theorem comes from. Since we have 5 terms here, we are going to do 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. And that's going to be what our coefficient is. What is 5 choose 0? 5 choose 0 is 1. So that's going to end up being just an x to the 5th. What's 5 choose 1? Do you remember what that is and how you figure that out? Do you remember? You want to look it up? Or you want me to tell you? I think I'm going to let you look it up. But I know the answer is going to be 5 x to the 4th y. 5 choose 2. And I'm going to cheat by looking at my triangle, is going to be 10 x cubed y squared plus 5 choose 3, which is also 10 x squared y cubed. Isn't that interesting how these numbers reversed, but they were exactly the coefficients stayed the same here, even though we use the same numbers there. And then I'm going to have 5 choose 4, which is again going to be a 5x y to the 4th. And finally, 5 choose 5 is just 1, so then that's going to be y to the 5th. And that's how you do that expansion. And that's all the binomial theorem is saying. And if you look carefully and take apart all the pieces, you will find that the theorem that is written in your book on the top of page 349 says exactly this. It's just adding a bunch of things together. And this is there exactly, and that the exponents are always going to add up to the total of n for whatever number it is that you're looking at. So that was a little bit confusing, and you're going to say, but wait a minute, Miss Holly, that didn't really work for our expansion of x plus 2 to the 4th power. Remember when we did that right away at the beginning, x plus 2 to the 4th turned out to be this. Now I don't see any y's in there, and I don't see any kind of symmetry on these coefficients. So what happened? How do I do x plus 2 to the 4th using the binomial expansion? Because that isn't at all what I see happening here. Well, let's think about it again. We are doing x plus 2 to the 4th power. And we're going to see if we got exactly the same answer that we got right away at the beginning of this lecture. So how do we do that? Let's think again. Well, I know I'm going to have x and I'm going to have 2. So I'm going to have x to the 4th plus x cubed times 2 plus x squared times 2 squared plus x times 2 cubed plus 2 to the 4th. And that's just for the numbers that are inside the coefficient, or inside the parentheses. I still have to deal with the coefficients separately. And remember that my that my coefficients are always going to be the exponent 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. So what is 4 choose 0? 4 choose 0 is 1, so that just leaves me with x to the 4th. 4 choose 1 is going to be 4 times 2x cubed. I just rewrote that 2 over there, and x cubed. What's 4 choose 2? 4 choose 2 is going to be 6. So 6 times 4, which is that 2 squared, times x squared, plus 4 choose 3, which is 4, times 2 cubed is 8 times x, plus 4 choose 4, which is 1. 1 times 2 to the 4th, and 2 to the 4th is going to be 16. So that gives me x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. And if I find that first sheet again that we did at the very beginning of class, oh, here, let's bring it down a bit. This is what we did at the beginning of class, where we had x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. It's the same answer, but on this one we use the distributive property, and on this one we used binomial expansion, the binomial theorem. How's that? You get the same answer either way. Now, if you, when you have to do a large expansion, like something to the 10th power, if you would rather go through and do your distributive property all the way through, you feel free to do that. However, you are likely to make a silly algebra or arithmetic mistake somewhere along the line. This is going to be more foolproof for you. You're going to find fewer mistakes if you learn to use the binomial theorem. So that's all well and good for when we need to do the entire expansion, but sometimes our lesson is not going to be to do the entire expansion, but it's just going to say, let's find the 5th term of a particular problem, a particular exercise. So how would I do that? Well, let me write out that binomial theorem for you again. The binomial theorem says that a plus b to the n power is going to be the sum, as r goes from 0 to n. I said that your book did it in a more complicated way. For n, choose r, a to the n minus r times b to the r, and where n choose r is equal to n factorial over r factorial times n minus r factorial. Okay, now that's a lot of work. But let's think about what all of these things mean. This symbol right here is just the summation symbol, which means that we're going to take all of these things and we're going to add a bunch of things up. The first time we add anything up here, we're going to say r is 0. And n is going to be the maximum number that we're going to look at. So if we are looking, n here is the same exponent. So if we're looking for something to the 10th power, n is going to be 10 all the way through. The first time we're going to do it, but we're going to have to add it up 10 different times. The first time r is going to be 0. The second time r will be 1, 2, 3, 4, 5. So if we're looking for just the 5th term of something, well, the r equals 0 is going to be the first term. R equals 1 will be the second term. R equals 2 is the third term. You can see how that goes. So if we're looking for the 5th term of something, that's going to happen when r is equal to 4. Okay. Again, what are you talking about, Miss Holly? How is this going to help me get my homework? Because ultimately, that's the important thing, is getting the homework done, right? Well, remember, this is going to be your binomial expansion. This is the binomial theorem. This is what you need to put on a note sheet so that you can use it for your next test. And what you're going to see on the test or someplace when you're using this math is you're going to have something like p plus q to the 10th power, and it's going to say find the 5th term. 5th term. Okay. Find the 5th term. So the 5th term is when r is equal to 4. So I don't need to do the whole summation. I only need to find the term when r is equal to 4. So n in this case is 10. N is 10. R is 4. So 10 choose 4 times p to the n minus r. N is 10. R is 4. N minus r is 6. n times q to the r. In this case, r is 4. And what is 10 choose 4? Well, this time, I'll let you have that cheat out here. This is what n choose r means. So if n is 10, we're going to have 10 factorial over 4 factorial times 6 factorial. 10 factorial over 6 factorial is going to be 10 times 9 times 8 times 7 times 6 factorial all over 6 factorial and 4 factorial. Those cancel. That leaves us with 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1. 4 and 2 are going to be 8. 3 goes into 9 3 times. So that leaves us with 10 times 3 times 7. 21 times 10 is 210. So the fifth term, 10 choose 4, is going to be 210 p to the 6th q to the 4th. That will be the fifth term of our expansion. And that's the only one we care about. All right, so that was a little bit crazy. Let's try another example. Let's see if we can find something a little bit more complicated. I'll do another example from your book. I'm actually going to do letter D from your lesson practice, where it says find the fourth term of the expansion, x plus 3 to the 10th. And we want to find the fourth term. Fourth term. What is n on this one? N is the exponent. N is going to be 10. Fourth term means what do we want to find as r? If it's remember, r is 0 is the first term, r is 1 is the second term. So we want to find r is 3. We want to find the fourth term. Okay. Looking back at our binomial expansion, we only want to find the fourth term, so we don't have to add them all up again. We just want to do 10 choose 3. And in this case, our a is x. So we're going to have x, n minus r. N minus r is 7. Our b is a 3 times 3, and r again is cubed. 3 is a 3. How do I calculate 10 choose 3? Well, that's going to be 10 factorial over 3 factorial, 7 factorial. That's 10 times 9 times 8 times 7 factorial over 3 times 2 times 1 times 7 factorial. Those cancel. 3 leaves a 3, 2 leaves a 4. So we have 3 times 4, which is 12, times 10. This is going to be 120. So 10 choose 3 is 120 x to the 7th times 3 cubed, which is 27. 27 times 120 is 14, 5, and 7, 2, 0, 1, 810. So that leaves me with 810 x to the 7th as my final answer. And I think I did something wrong here. Hold on, let me double check because that doesn't feel right to me. 0, 0, 14, 4, 5. And then I have to bring this 7 over here. Sorry. I believe 4, 5 and 7 is 12, carry 3240. Sorry, just a little bit arithmetic mistake, and I think that is going to be a better answer when you multiply it out. You could always use your calculator if you don't trust your multiplication, like I probably should have done on this time. So anyway, 3240 is times x to the 7th will be the fourth term of that when we multiply it out. I want you to go ahead and make sure you finish up the rest of those lesson practice problems before class. And if you have any questions, we'll talk about them then. Enjoy your homework. Have a good night.